In this video, I'm going to show you how to do a PowerPoint presentation or PowerPoint slideshow with the combination circuit that we just drew in CAD. So we're going to do our calculations and we're going to move our pictures. We're going to export our pictures out of CAD and put it in our PowerPoint. So I want to let you to be a little creative here. I want you to pick your own theme. So if you just open PowerPoint, you should come to this screen and there should be a thing at the top that says more themes, and you can pick out whatever theme you would like. There's a bunch of them there, and you can even find some more if you would want to search for them. There's different types of themes you can have at the top, and you can pick different things. I like the ocean, so I'm just going to pick the one that has the picture of an ocean up there. And I'm going to create this. Now you can be creative. The ocean doesn't really apply to our electrical circuits, but you can put whatever you really want. And I'm going to put our combination circuit. That's going to be the name of our presentation. And you can change the font to make it whatever you want to. I kind of like the Argentinian, but you can make it whatever you want. Be a little creative with this. If you want to add something at the bottom too, I'm not going to be too concerned about that. But I would like for you to go to AutoCAD, and I would like for you to go to your original drawing. It has the whole circuit in it. I want you to select it all like we did in the past, and then we're going to copy it and we're going to put it into our PowerPoint presentation, and then we can do paste and just paste it as a picture, and we'll have to format it because it's really big, so you can format your picture, and then we're going to crop it. I'd like for you to crop it just about the size of the picture, and then you can click off of it and you can move this around. But at the bottom of the top over here, it gives you some designs so that you can move it however you like. And again, I'm going to let you be creative, and you can pick what you would like. You can make your picture a little, your circuit a little bigger. And again, just kind of be a little creative with it and do whatever you want. But whenever we do the rest of it, I would like for you to just use the blank page that we have down here. So I'm going to go ahead and delete all the rest of these right now. Just click on them and hit the delete button. And I will show you how we're going to make the more tiles as we go. So this is our different page. Again, I want to change this. We're not going to be using these. We'll be using this text box, so save the box. Up here at the top, you can again put your title. You can copy it from this side if you would like. Just hit Control-C and bring it to here if you would like. You can highlight that and paste your copy up there. But we're going to call this, and I want you to hit Enter, put this on the other line. We're going to say equivalent resistor, so we're going to call it REQ1 calculations. So we're going to redraw our circuit and do it in calculations. Now this font is kind of okay for the title, but here I would like to do a different font. I'm going to do it in Arial, which is a very common font that most people use for our title here. So what I'd like for you to do is to copy the original drawing, and we're going to copy the original drawing and put it on the side and paste it into this. And again, you can make it a little smaller here and put it on the left side of our text. Okay, now that you have your original drawing in there, I want you to go back to AutoCAD, and I want you to select your equivalent resistance circuit. That should be in layout number 2. You can just highlight the whole thing and do a Control-C and copy that drawing. And we'll go back into our PowerPoint, and I want you to paste it. So again, we can do a paste. Have to paste it as a picture. And then we want to do a picture format, and I want you to crop it and make it the size that you want it. I grabbed the wrong line. So we'll crop it to a smaller size. So we're not moving the whole thing. Make sure you get it all. It looks a little like it's over the other one, but we'll fix that. You have to click off of the drawing and then click back on it, and then you can move it to where you would like it. Try to get it fairly close to the same size as your other one. You can adjust your picture over here to get on the same size. This is a little too big just because it has more stuff on it. But just kind of play with it till you get it approximately the same size to just make it look a little more, make it look neater. So what we're going to do here in the text box is we're going to delete this stuff and we're going to add our formulas. So we're just going to put to find REQ1. We need to add R3 to R4. And then we're going to bring another line down here and then put REQ and then a space equals space R3 space plus R4. And then we're going to do R equals REQ equals 1K plus 5.7K. And then one more time, REQ1 equals, and that should be 6.7K. I would like for you to put the ohms in there. If you come up here to insert, it lets you insert symbols. And you can insert the ohm signal. Click the ohm signal, hit insert, and it will put the ohm signal in for you. I would like for you to copy that and put it behind the other resistor values so that they are all in that resistor values. So this will be our page number 2, all of your values. Make sure this is centered. You notice you get lines that will show you that it is centered in between the two circuits. Once you're happy with this, and this could be a little bigger here too, we can make this come to the center of our drawings, and you can make the font a little bigger. So you can play with this to kind of make it look as neat as you would like for it to look. I want you to make it look as neat as possible. So then whenever you're ready to go to the next page, and this page is complete, so now we need to go to make REQ2. And what I would like for you to do is just come back here and select this page, and then we can copy, Control C, and hit Control V. So that will add you another page, and you can make this equivalent resistor 2 calculations. And I would like for you to do kind of the same thing. We're going to delete this circuit, and we're going to move this circuit to the other side. So this is our original circuit, and we want to add our other circuit here. I'm not going to go through all of this for you. I'm going to let you do this. So you go to AutoCAD, you'd copy that next circuit, you'd paste it in here, you'd crop the picture, and then to find our REQ2, we're going to have to use the formula of 1 over the 1 over R2 plus the 1 over REQ. So we will write that formula and then put your values in there and do the calculations and come up with your total equivalent resistance. Once you have your equivalent resistance 2 calculations done, we'll copy this and paste this. And then I want you to do your total resistance calculations. And that will be adding your REQ2 with R1, and then that would be how you calculate your total resistance. And then we'll move on to go find your total current. Total current is just simply your voltage source divided by your RT. So whatever you calculated for RT, you'd take 12 volts divided by that, and that will give you your total current. So now we're going to calculate the voltage drop across R1 and REQ2. So if we know our series circuit, we know that our current is the same. So when we find our total current, it will be the same amount of current going through R1 and REQ. This is just a simple series circuit. So to find our voltage drop across R1, we will take our total current times R1. And again, I'm going to let you calculate your total current, but R1 should be 25K, and that will be your voltage drop across R1. And we're going to find our voltage drop across our equivalent resistance, and that will be, again, our total current times our equivalent resistance, and that will be the voltage. Now that we found our voltage drop across our REQ, we want to copy this slide and make a new slide. And then we want to find the current that is going to flow through our R2 and the current that is going to flow through our equivalent resistor 1 here. Now, if we know about our parallel circuits and voltage, the voltage drop across here is just the current through this resistor. And then the voltage drop here is the current through this resistor. But then that voltage drop would be the same. These two are in parallel. So our voltage drop across R2 will be the same as our voltage drop across REQ. So we can take that voltage divided by R2 and find the current that is flowing this way. There's a couple different ways. We could just subtract that current from our total current here and find the current going through this resistor. Or we could take the voltage drop across this equivalent resistor divided by the equivalent resistance, and that will find us our current. Okay, so once we know our current flowing through this branch of the circuit, our IREQ1, then we can find our voltage drop across our last two resistors. This will be the last of our calculations. So to find the voltage drop across VR3, it's just your current of that equivalent resistance, the current going through this branch, times R3, and that will be your VR3. We'll take the same thing, the current through this branch again, times R4, which is 5.7K, and that will be your voltage of VR4. So VR3 and VR4 should equal your VR2 because those two are in parallel, they have the same resistance value. And you should have this current and this current should equal our total current. So all of our current is coming out of the battery going through here. Some of it is going this way, some of it is going this way. It all should come back together, back to our voltage source. So when we're done with our calculations, I want you to make one more slide. Just copy this and make your last slide an answer table. And to do an answer table, we're going to go to Insert and we're going to Table. And I want you to go over, if you move your mouse across the top, it shows you how many you have. So I want to go 6, and then I want to go down 4. And if you notice at the top, it says 6x4 table. So you want to add a 6x4 table. And click it, move your mouse till you get like the crosshair things, and you click and drag and move it, kind of center it in your slide the best you can. I am not crazy about this maroon color. You can change the color at the top to do whatever. There's more choices there, a gazillion choices, but you can choose whatever you would like. Across the top, I would like to put your resistors, just R1, and this will be R2, and this will be R3, and so on and so forth. And then the last one is going to be your total. And then over here, I'd like to put your resistance. And then your current. And then lastly, your voltage down here. So when you get your table made, you just fill in these values. So you should know R1 is given, R2 is given, R3 is given, R4 is given. Your total voltage down here is given as well. So that would be what you would put for your total voltage. Not sure where that came from, but your total voltage would be like 12. And I want you to use volts. And I want you to use your engineering notation for your resistance, K ohms. And then your current is probably going to be a milliamp. So I want you to use your engineering notation for those. And then your total. So this will be your total resistance. This will be your total voltage. This will be the current going through R1, the current going through R2, and then the voltage across to R1, R2, and R3, and R4, and then complete that. So your PowerPoint presentation should look something like this. You should have a cover page that shows you the total circuit, and then we should have where we're doing our resistor calculations, where we count our equivalent resistance for R1 and then R2, and then our total resistance, and then we kind of work our circuit backwards, where we find our current through each of these resistors and our voltage drop. And then once we have our voltage drop here, we can do our parallel branch. We know how much current is going here and how much current is going there. And then find the voltage drop across those resistors and then finish our table. And then we'll save this under a combination circuit and then submit it in Blackboard.